All right, so now we're going to go ahead and look at the assignment titled Congruent Rectangles. This one is much like the last one, Congruent Segments, where it's kind of an odd question. It's more theoretical than some of the ones we normally do, but that's okay. That means that it's once we get through it, it won't be too bad. So let's go ahead and take a look at the problem that we're dealing with. So let's go ahead and just read along. So it says below is a picture of two rectangles with the same length and width. Okay, so that means for us that we have a rectangle, rectangle 2, and rectangle 1 that are the exact same rectangle. Okay, we know that the sides of them are identical. You know, their measurements are the same. And what we're going to be doing is going to depend on the question, but in the first question, we're going to show that these two rectangles are the same, okay? So we're going to be looking to do transformations to move rectangle 2 into the same position as rectangle 1. And if we read A, it says we want to show that the rectangles are congruent by finding a translation. So we're going to translate it first, and then we're going to rotate. Okay, and we're going to map the two rectangles onto each other. Okay, so first thing we want to do is just remember some definitions. Okay, so first of all, translations or a translate is just a slide where we take our shape and we just move it to a new position on the graph. Okay, in a rotation, on the other hand, we're going to pick one point and we're going to spin, we're going to rotate everything else around that one point. Okay, so logic dictates that in order to be able to rotate rectangle 2 onto rectangle 1, well, the easiest way to do that is going to be making one of these points match up. Okay, so I've identified kind of what I identified as the top left point of rectangle 2 and the top left point of rectangle 1. Okay, so that means if I want these two rectangles to match up, I need to make those 2 points match up. Okay, so we're going to start with a translation. And remember, this one is just a slide. So use these first sets of points to figure out how much you're going to move them by. Okay, so we're going to go down 1, 2, 3, 4, 5, looks like. And we're going to go right 1, 2, 3, 4, 5, 6. So we had down 5 and we had right 6. Okay, so that means that I need to do that exact same move for the other points as well. Okay, so I'm going to do one of these just to show you, but then you're going to go through and do all of them. So I'm going to take this second point, I'm going to go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, and I'll mark my new point. Okay, and then you're going to repeat that process through the rest of the rectangle. Okay, that will leave us with a shape that looks like this. Okay, so now we've done our translation. Now we have our new points in, and you'll notice I marked this point, this angle A. Okay, now we need to do a rotation. Okay, so in class we did most of our rotation around the origin. Okay, so that means that, well, we don't really have a coordinate axis here. We don't have an origin, okay? But if I wanted to, I could make one, okay? So if I drew in an XY and I made this point my origin, okay, I'm essentially rotating rectangle 2 around that point. So that means that point P is going to stay in place. It is the point that we're rotating around. It's not going to spin, but every other point will spin, okay? And because we want to make PO line up where PS is currently, okay, the way we're going to do this is we are going to rotate whatever the measurement that angle A is, okay? Now, if you look at angle A, does angle A look like a 90 degree? Does it look like a perfect, corner like that? No, definitely not, right? It is definitely an acute angle. It's going to be definitely smaller than 90. But beyond that, it's a little bit out of our scope to actually come up with a measurement of angle A. So you're going to rotate around, for us, I labeled it as point P. Okay, so we're going to rotate around point P. By an angle of angle OPS. Okay, and again, the goal is to make PO turn into PS, because once we've done that, we'll have shown that those two rectangles are the same. Okay, so A was a little strange. Most of this assignment's going to be a little strange, but it's a good question. It's an important idea. It's an important visualization exercise. Okay, so it's a good skill to start building on here. All right, let's go ahead and take a look at part B. Okay, so part B says, explain why the congruence of the two rectangles cannot be shown by translating rectangle 1 to rectangle 2. So we did that. Okay, we did that right here. Now, if you can probably look at this picture and tell me why I can't tell you that rectangle 2 and rectangle 1 are the same anymore. Okay? The reason why that's the case is because I don't know that they're the same just yet. Right? This rectangle 2 is tilted compared to rectangle 1. And I can say they're both rectangles. I can say they look very similar, but I would not know that they are the exact same without actually doing that final rotation and moving them on to each other. Okay, so we have one more problem to look at. This is problem C, okay, which says, can the congruence of the two rectangles be shown with a single reflection? So this is going to be very similar to what we did in the last section in the congruent segment section. So first thing, remember that a reflection is a flip over a line. It's essentially a line representing almost like a mirror, and you're showing the reflection on the other side of the mirror. Okay, so let's go ahead and start looking at this one a little more directly. So I want to draw, if you watch the one about the congruent segments, I talked a lot about the view line, or what I like to, when you connect the two things that are going to be the same. Okay, so when we're flipping, we're going to be looking to make this point the same, and this point the same, and this point the same, and this point the same. Okay, the problem with those lines is that I don't think I can really draw a mirror through the middle of them. So for example, if I just look at this first one, yeah, sure, I can make a point that maps the purple point onto the orange point, the point from rectangle 2 onto rectangle 1. It's going to be pretty nicely here, right through the middle of the graph. Okay, so in order for those 2 points to line up, they would have to reflect over that axis. Okay, the problem is, though, is like, for example, if I look up at this point, okay, well, sure, I can do that reflection, but that point isn't going to go all the way down here, right? It's going to end up somewhere. Let me change colors again to emphasize it a little bit. It's going to show it somewhere kind of down here. Okay, so it is possible to make multiple reflections that will turn us into rectangle 1 from rectangle 2. But because it says, can it be done in a single reflection, my argument is no. Okay? Because it isn't obvious where the two lines cross. Okay? Because one axis of reflection won't move all the points onto each other. Now, if the rectangle was oriented a little differently, like, for example, if it was flat on this, and again, I'm just kind of freehanding, okay, that one could work, right? Because then you're talking about, oh man, I did it perfectly. Okay, then you're talking about two rectangles that would be the same. So in order to do this in a single reflection, we would have to do a rotation first and then reflect onto rectangle 1. Okay, so make sure you give us a good write-up for this one. Try to do your best to sketch it out.
talk through your doing. Write some sentences alongside your work so it's easy to see kind of what you guys are doing, and use this as a model. I pretty much went through all the questions. You guys just need to kind of work out, just kind of record it and write down the final answers.